and switch. All right. So let's get started here with the exponential functions. We worked with exponential expressions. Now we're going to do with functions. So an exponential function of a base of a is given the following, where a is greater than 0. We'll leave a greater than 0 for now, and a is not equal to 1, and raise it to the x power. Note if a is less than 0, have both real and imaginary parts, which is not part of this course. If you get into Math 432, for some of you engineering, especially for electrical engineering, you're going to want that class. It's complex analysis. We do get into that, but that's a long way from now for some of you. Okay, so let's crunch through some of this. So here, I just want you to state what is the base. What is the base of this? Well, the base of, so an exponential function, usually a is raised to some x power or some variable power. So the base here is 23. The base here is 2/7, and the base here is y. Okay, so it's what is being raised to what power. Just for kicks, if I had q to the h and I had x to the h power, the base here is x, right? It's not what's raised to the x power, it's what is my function, what does my function variable raised to what is raised to that, okay? All right, so let's learn how to graph these for a second. All right, so we're gonna graph these. Let's just put in the easiest x's I can think of. So let's put in 1, 2, 3, -1, -2, -3. Why? Because that's the power we're going to raise it to. So anything raised to the 0 power, because we're gonna graph 2 to the x and 1/2 to the x. Anything raised to the 0 power is, of course, 1. Right? That comes from our rules. Here, 2 raised to the first power. 2 to the first power is just 2. 2 to the second power is, of course, 4. 2 to the third power is 8. And here, 2 to the -1 power is 1/2, so that's 1/2. Here, this will be a 4th, and this will be an 1/8. Okay. So let's go ahead and graph that. And so here, 0 will have 1. Here will be at 2. At 2 will be at 4. Hold on, that's not 2. This is 2. This is 4. And this is 8. And here we're at 1/2. Here we're at a 4th. Here we're at 8th. And so over here we can kind of sketch this in. All right. And this is going to be the same. So this is the same pattern for all a greater than 1. Will look something like this, right? It might be more steep. It might be way more steep. It might be barely going up like this. It depends on where your a value is. Depends on what this is. So if a is greater than 1, they're all going to look like this. They all go through this point. They all go through this point right here. In fact, let me switch colors. Let's grab, I don't know, teal. Let's do the 1/2 here. I'm at 1, right? Let's grab a slightly darker teal. Here I'm at 1. Now that's not very distinguishable. Let's grab that. 1. Here at 1, I'll be a 1/2. Here at this, if I square this, I get a 4th. Here I'll get an 1/8, and this, of course, will be 2, 4, and 8. I'm just crunching through 1/2 to raise to these powers. And so here, I'm still at 0, I'm still at 1, right? I still go through this point, and now I'm just, in this case, I'm just backwards from where I was. Here would be a 1/2, a 4th, an 8th, and so it comes in, goes down like this. Okay, and here's the same pattern for a less than 1 but greater than 0. Okay. And so all our graphs looks vaguely like this. So the exponential graph goes up like this, or if it's less than 1, it comes down like this. We call this exponential growth. This is exponential decay, right? You work with both of these a lot in science classes. All right. So let's get some general ideas. So one thing I like to teach is generalities, and so that helps you to do things. All right, let's go back to black for a second. So, all right, so the exponential function, let's talk about some things. So if a is greater than 0 and a is not equal to 1, the domain is all real. So you can do all reals. The range is from 0 to infinity. That means y equals 0 is a horizontal asymptote, right? And since we've gone over asymptotes for a long time, in this case, it's a true asymptote. It's a line the graph approaches but never crosses or reaches, unlike the other asymptotes, which were fake asymptotes or pseudo asymptotes. So for every graph of a, we're always going to go through the point 0, 1. And then it just looks like this. So all graphs look the same like this. And depending on different values of a, if I have a really strong value of a, it might come up like this. If I have a really big a, it might come up like this. If I have an a that's like 1.1, right, it might come up like this, be kind of slow. Here for a, less than that, it's still going to go to the point 0, 1. And the reason it still goes to this point because anything raised to 0 is 1. And it comes in and goes like this. Now the reason we go over this because we're going to move them around, right? We're going to move them around. And so you're going to do a couple of these graph transformations. So here, how have I transformed this graph? How have I transformed my exponential graph by doing this? I'll let you guys answer this one. What have I done to the exponential graph? How have I moved the graph on this one? It will shrink, move down by 1. I'm going to say everything with a question mark just to bug you guys. The answer is it goes down by 1. Here I'm shifting it down by 1. Okay. So here I can write this the same thing as writing this 2 to the x minus 1. So it's moving it down 1. So here, instead of being here's my point, here's going to be my point, here's going to be my asymptote. My asymptote also moves down by 1. And so it looks like this. Okay. Here, what have I done to this graph? Well, I've moved it to the stretch by 2. Actually, no, because 2 is technically part of the base here. And so we haven't stretched or shrinked it. So see if I can write one. If I wrote 2 times 3 to the x here, I've stretched it by 2. If I had 2 times 2 to the x, well, I just put this in as 2 to the x plus 1. So, and then I just graph this, which is the same as doing that, strangely enough. For this one, here we're going to move it to the left. Here, no, it's negative, so we're going to move it to the right one. So here I'm replacing my x with x minus 1, so I move it to the right one. And then I flip the whole thing over the x-axis, so it's actually here is my starting point. And then I guess I just graph it in. All right. So you'll be doing transformations. So you get used, that way you feel comfortable with the graph of the exponential. Yeah, so the right one, and then I flip it upside down. Okay. All right, so let's talk about interest for 5 minutes, and that's it for the day once we do interest. If we need to do more practice problems, that's perfectly okay by me. All right, so let's talk about interest. So here we're going to talk about compound interest. So we're at t, so here's the formula for interest. So the amount in the account after t years is the principal, how much I put in. So this is how much I put in. which I put in or took out. Put my graph's getting slow in or took out, depends on which way you think about it. Interest rate per year. So if I had 5%, please remember to write this as a decimal. So write this, or if I had 16%, right, this is 0.16, right? And if I had 7.2%, write this as 0.072. So please put it in a decimal point. If not, you're giving really, really high yields, and then you can manage all my bank accounts and make me loads of money. So, n is number of times it's compounded, so how often we compound the interest. Okay, and so we're gonna do a student loan, right? Because most of you may or may not end up taking student loans, and I just want to give you a fair warning of what you end up doing. Did I take out student loans? Yes. Am I paying out the nose for them? Yes. Are my student loans probably ever going to be bigger than your guys's? I sure hope so. Not in the sense that it's good for me, but I owe a small house earning a PhD. Oh boy. Anyway, so let's run through this. So I'll do the first one. I'll have you guys do the second one, and then I'll do the other. True. Okay. So here, if I'm going to do this annually, so here I'm going to do it annually, which means I compound it once a year. Semi-annually means twice a year. Monthly means 12 times, and this means 356 times, right? So here, if I'm going to do this, here my principal, I put in, or I'm taking out 300,000 or 30,000. My rate is 7 per year. So 1 plus, and so my 7 per year would be 0.07, right? 7%. So we write this as a decimal. How many times am I doing this? Well, I'm just doing it 1. And for how long? We're going to do it for 4 years. Okay, so it'll be 1 times 4. Okay, so here my n is 1 because that's how many times I compounded it. My t is 4. My principal here is 30,000. And so I crunch this number. How do I crunch this number? I type it in a calculator, right? So after crunching it through a calculator, after 4 years, I owe 39,332.88. Okay. All right, so you guys crunch through one number for me. So crunch through here, n is equal to 1. Oops, here's n equal to 1. So do the semi-annual. Semi-annual is n equals 2, so this is semi-annual. So crunch through that one, and I'll give you the other two. This is semi-annually, this is annually. So crunch through that. Must be scary. That must be scary for the student. Yes, yes it is. I signed up for loans at 3%. And then since a bill didn't pass in Congress, they went to 6.5%. And then my graduation got delayed 3 years, and so it just get carried interest for 3 years. I'm like, oh my goodness. And so a simple loan got really out of hand really fast. Welcome to life. That's fine. You just deal with problems as they come to you. That's what life is, a series of problems. Let me rephrase that. Life is a series of puzzles which you solve as they come to you. If you think of as problems, you'll get in trouble. Almost. Yeah, so that's the correct answer. So we got someone's correct answer. So let's type it in together, and then we'll figure out. So I still have 30,000. That's still my thing. I'm gonna have 1 plus 0.07 divided by 2, and then I'll have 2 times to the 4th, right? And so if I crunch this through a calculator, let's actually type one in the calculator with you guys. Our calculator for this class is Wolfram Alpha. Why? Because I can guarantee everyone has it. It's free. It's here. Let's enjoy it, right? So here I type in $30,000. I'm going to multiply this by, oh, there's someone already has like almost done. going to turn 1 plus 0.077 divided by 2. Quantity of 2 times 4. I forgot. I forgot something. There we go. And here we get the amount. Okay. And so let me write this amount down. That over. And so here we got the amount of. When you do this on the exam, I'm going to have you round to the nearest dollar, so don't put point anything on it. So here, and that'll be 27. Okay. Here, if we do n equals 12, let's do 12. And so since I already have it typed in my calculator, this makes it really easy. Hello, I lost my screen. There it is. Here, we just plug in a 12 and 12. Here I get $39,661. I'm just going to round to the dollar now. So this will be 39661. I guess I'll put it at 62. And then n to the 365. I did it every day. I already have the number pre-calculated, so it's 39692.61. So notice the more times I compound it, the more money I get, right? So guess how many times your bank, when you take out a loan, compounds your interest? Is it every year? Is it every, so are they doing it every year? They're doing it every semi-annually, once a month, daily, depends, does depend. Depends on the loan. 90% of all loans are done continuously. In fact, they do it faster than every microsecond for calculating your interest. And adding it to it, right? We'll actually teach you how to do that next time. And so there's a way of doing it. So this seems to be crashing to some number. What number that is, we'll find out next time. Yeah, I feel like a bad sitcom. Find out next time. Will Batman be saved? Will the Joker get away, right?